In this video we're going to start chapter 6, and so the first section is simplifying rational expressions. Alright, I'm going to make this a little bit thicker here. Whoop. Alright, so topic 1 is determine the values oh boy, for which a rational expression is defined. Alright, so that was probably overkill here. So, remember that a rational expression is just going to be a fraction. So it's an expression of the form p over q, where p and q are polynomials and q is not equal to 0. Meaning that it's a fraction with variables in it, or a fraction with letters in it. So, determine the values for which each rational expression is defined. Now remember, this q is not equal to 0 is just saying that the denominator cannot equal 0. So we have the denominator of this 5 over x plus 10 cannot equal 0. So x plus 10 cannot equal 0. And so if we subtract the 10, we have x cannot equal negative 10. So this is defined for all real numbers except negative 10. Alright, so let's try the next one. We're going to do this one very similarly. X minus 7 over 3x plus 5. Again, we know that the denominator cannot equal 0. So 3x plus 5 cannot equal 0. We're going to subtract the 5 and divide by 3. So we know that x cannot equal negative 5 over 3. So this is defined for all real numbers except x is equal to negative 5 over 3. Again, you can think about it like this. We can substitute any number in for x except for negative 5 over 3, and we won't not get a 0 in the denominator. Alright. The same thing for c, x plus 3 over x squared minus 2x minus 15. We know the denominator cannot equal 0. So x squared minus 2x minus 15 cannot equal 0. We have to factor this one to numbers that multiply to negative 15 and add up to negative 2. So that would be a negative 5 and a positive 3. You can check that by FOILing if you would like. Then neither of the factors can equal to 0. So x minus 5 cannot equal 0, and x plus 3 cannot equal 0. So if we add the 5, x cannot equal 5, and if we subtract the 3, x cannot equal negative 3. So this one is actually defined for all real numbers except negative 3 and 5. Any questions about this, please direct them to Rod. I'm sure he would be more than happy to help. But with that being said, again, in all honesty, if you guys do have any questions, please feel free to email me or bring them to the next class. Alright, let's move on to the next page, 199. Understand the three signs of a fraction. So just remember again, I know that I say this a lot, and I've said it before, I'm sure, that the negative on a fraction can be on the top, the numerator, right next to the fraction bar, or underneath in the denominator. As long as there's one negative somewhere, the whole fraction is negative. So if I want to have 5 over negative 8, I can write that in two other equivalent forms. If the negative is in the denominator, I can actually put it in the numerator to get negative well, that's still not good. To get, okay then, to get negative 5 over 8, or right next to the fraction bar to get negative 5 over 8. Okay, so that's a pretty simple concept, but sometimes it's hard for people to remember that. If there is just one negative, again, the whole fraction is negative. It doesn't matter where in the fraction the negative is. Let's move on to topic 3, simplify rational expressions. So we're going to factor the numerator and denominator, and then cancel any common factors. So we have a here, 14 x to the third y to the second over 21 x squared y to the fifth. So let's factor the 14. That's 2 times 7. And then we have x to the third, x, y squared, y. Then we have the 21. That's 3 times 7. So 3 times 7, x squared is x. And then y to the fifth is y. So can any of the common factors cancel? Yes, a 7, an x, a y. So what are we left with? We're left with an x. Maybe I should do a darker color. An x and a 2 in the numerator, and a 3 and 3 y's in the denominator. So that will give us 2x over 3y squared. Again, if you can do all of this without writing it out, more power to ya. Alright, B. 12x to the third plus 6x squared minus 30x over 12x squared. This one, you have to be careful because the monomial, or the one-term polynomial, is in the denominator. So I can actually split this up sort of in a couple of ways, but one of them is just 12x to the third over 12x squared plus 6x squared over 12x squared minus 30x over 12x squared. Now I can reduce each of these individually, so 12 over 12, goodbye, and x cubed over x squared, that's x. Then I have these x squareds cancel, so 6 over 12 is just a half, and then minus, and what do I have here? 30 over 12 reduces to 5 over 2, and then I have x over x squared. There's more x's in the denominator, so when I cancel an x, that last x stays in the denominator. Now, that's one method for doing this. I do want to point out that sometimes it may be useful to factor the numerator instead of breaking it up into 3 fractions like this. And here's what I mean by that. If I look at just the numerator, right? Alright, I have a GCF of 6x. So that means that the numerator is actually 6x times 2x squared plus x minus 5. This is a factor. I know that this is actually 6x times 2x squared plus x minus 5 all over 12x squared. Then I could cancel the 6's out, so that makes that a 2, and then the x out, so that just leaves x here. So I actually would be left with, let me pick a darker color here, 2x squared plus x minus 5 all over 2x. But if I write it out as 2x squared over 2x plus x over 2x minus 5 over 2x I end up with the same answer as before, x plus a half minus 5 over 2x. So again, either way is fine. I think this first way was a little bit easier for me at least. Alright, so again, if you have any questions, feel free to ask, send me an email, or bring them to the next class. Alright, C. In C, this is a little bit different because this monomial or one-term polynomial is in the numerator. So let's start by factoring the denominator, and I see a GCF of 5x. So it's going to be 5x times 3x squared minus 5x minus 1. So this is still 10x over the 5x times the 3x squared minus the 5x minus the 1. Then the 5 goes into the 10 twice. The x's cancel. So I have 2 over 3x squared minus 5x minus 1. And again, I can't break that up any further because the monomial was in the numerator this time and not in the denominator. Alright, so let's move on to page 200. We've made it to the 200s. Alright, so let's look at D. In D, I need to factor both the numerator and the denominator. So for the numerator, I need two numbers that multiply to give you 18 and add up to give you 9. So that would be a 6 and a 3. And then for the denominator, I need two numbers that multiply to give you the 15 but add up to give you the 8. So that would be 5 and 3. And then I hope that you see the exciting news I have for all of you. And the x plus 3's cancel. So this is x plus 6 over x plus 5. Kaboom. It is real. Alright, let's look at E. In E, this is an exciting problem for me because we get to go back to the difference of squares formula again. A squared minus b squared is a plus b, a minus b. So in the numerator we have x squared minus 10 squared, which is x plus 10, x minus 10. And the denominator is still x plus 10. And again, look at how exciting this is. It is so thrilling to cancel those x plus 10s. And that leaves me with x minus 10. Alright, F. F, again, this factoring might be a little bit more difficult for some of you still. So I'm going to do it off to the side. 3a squared plus 2a minus 8. Remember, I need to find numbers that multiply to 3 times negative 8 is negative 24 and add up to the 2. So that would be a 6a and a minus 4a. Then I factor out the GCF of 3a from the first two terms and the minus 4 from the second two terms. Then factor out the a plus 2. And I'm left with a plus 2 times 3a minus 4. Now, for the second part here, the denominator, I have 2a squared minus a minus 10, which I'm going to do very similarly. I need to know that 2 times negative 10 is negative 20. And then my numbers that would add up to the negative 1a right here would be a minus 5a and a plus 4a. Then I factor out the a from the first two terms and a 2 from the second two terms. Oh boy, this is about to go off the screen, but I think that all of you have ninja factoring skills at this point and would be able to do this. I believe in all of you. Alright, so now what I'm going to do next is actually just cancel out the common factor of a plus 2. So I'm left with 3a minus 4 over 2a minus 5. Let me box in all of the other answers on this page as well. So again, this is sort of a review of factoring if for some reason you missed all of those sections when I talked about that as well. Alright, so let's move on to the last page in this section here, and it's factoring a negative 1 from a polynomial. So we talked about that in the past, but if you look at example 4a, 5x minus 7 over 7 minus 5x, if I factor a negative 1 out of the denominator, that makes that into a 5x minus 7, and then you cancel the 5x minus 7, so it's actually negative 1. Alright. Again, if you're not sure what's going on here, negative 5x minus 7, how did I get that? You can distribute this to check negative 5x plus 7, and then you can rewrite the 7 first to get 7 minus 5x. And of course, 5x minus 7 over 5x minus 7 is 1, and so then that just becomes negative 1. Let's try the same thing for b. In the denominator, I don't want 3 minus n, so I'm going to change it to negative n minus 3. So again, putting that negative there reverses the order of the 3 and the n. And then I have to factor the numerator using the same methods as before. So 2 times 3 is 6. So I want numbers that would add up to the negative 7 also, which are going to be the minus 1n and minus 6n plus 3. Sorry, I cannot make that the same color. I can tell it's black now because I can see black because I'm colorblind, but I really cannot make that the same color, so you have to deal with that. So n times 2n minus 1, and then the GCF for the second two terms is negative 3, so negative 3 times 2n minus 1. Then factor out the GCF of 2n minus 1, so I have 2n minus 1 and minus 3. And then the most exciting part of the day where I cancel the n minus 3's. So I'm just left with negative, or the opposite of 2n minus 1. Kaboom! Alright, so let's move on to, I think, the last example in this section. So x minus 9 over 81 minus x squared. So usually I wouldn't want 81 minus x squared. I would want the x squared first. So I factor out a negative 1 to switch the order of the x squared and the 81. Then the x squared minus 81 is a difference of squares. So by now I hope that you would recognize that this is x plus 9, x minus 9. So this is x minus 9 over the opposite, or negative, of x plus 9, x minus 9. Then, kaboom! This cancels, and we have negative 1 over x plus 9. Again, it doesn't matter if I write it like that or if I keep the negative in the denominator. I usually prefer just to write it next to the fraction bar so I can drop all of those parentheses off and make it look a little bit nicer as well. So, I have great news. That is the end of section 6.1. I hope that you enjoyed this section today.